What happens if two air masses collide? Well, they will end up forming a front. Now, some of you have probably heard of the front line of battle. Well, way back in the day when you would have wars and they didn't have the same type of weapons as we have now, if they were fighting with swords, they would literally have to march up until they met one another. And if you were on that front line, you were first to meet that other side, and that's probably not going to look too good for you. I know I wouldn't want to be on the front line of a war like that. But the reason they call it the front line of battle is because it's where the two people, or the two rows of people in the front row, would meet and where the battle would begin. Well, the reason we call it a front in terms of weather is because that's the same thing that's going on, but with air masses. And so where those two air masses are meeting, they're having a battle to decide which air mass is going to take over the region and control the weather. So I know this isn't bolded, but you do need to write both of these bullets down. And this is just saying what I already said. Fronts two air masses meeting, or another way to think about it is the boundary that separates two air masses. So as you're copying this down, one thing that you may want to get, because we're going to write down 4 different fronts, as well as draw pictures of these fronts. Now, you do not have to have a colored pencil by any means. You can just label what's warm, what's cold. But I know a lot of students do a lot of students just like to have pretty notes. But other students like to have a colored pencil so that they can see which air mass easier. And so if that is you, either the pretty notes person or just I want to be able to understand my notes a little bit better, then feel free to get some colored pencils so that you can draw these as I am. So hopefully you've written that down. Let's go ahead and look at our first front. The first front is going to be a warm front. And so the things that you need to draw, let me underline. You do need, for everything, you need to write down the name. And then you need to write down what the symbol is. So that is the symbol of a warm front. And then I have the bolded stuff for what you need to write as well. So you're going to write the name of the front, the symbol of the front, the weather conditions associated with the front, and then we also are going to draw a picture of the front. The reason I'm making you write all these things down is because you have to know all of these things. They will give you a picture of a front and ask you to name the weather conditions. They will give you the symbol of the front. They will give you the weather conditions and then have you match it back up, vice versa. So you need to be able, or they may just talk about warm air moves into an area, what weather is likely to follow. Well, you need to know if warm air moves into area, that's a warm front, therefore you have light to moderate rain. So all of this stuff you've got to know, which is why we're going to write it down. So the warm front symbol are like your little scallops, that little half moon shape, that is called a scallop. Now, some of you may have had scallops before. If you have, it's a type of seafood. It's actually a type of shellfish. And scallops, when I think of them in terms of food, they tend to make me think of summer, because you typically eat most seafood in the summer. Some of you may think about if you have this may relate more to the girls, but in summer clothes, a lot of times you will see dresses or shorts that have the little scalloped pattern down at the bottom, and so maybe that can help you remember scallop. Or some people like to think of these as like little sunshines that are setting, and then you can think of the sunshines as being warm. So whatever can help you associate the scallop shape with a warm front. So a warm front is when warm area moves into the region. If warm area is moving in, it's a warm front. If cold air moves in, it is a cold front. So that's kind of the basics of it. So when you do your drawing, you can draw the picture that's already there, or you can draw what I'm going to draw. But you draw your front symbol pointing in the direction that the air is moving. So this is my warm air that I'm about to draw. So warm air, and this warm air is going up. It is going up and over cold air. So this is the cold air. So, and then I'll draw a line to show you where the grass is. So here's your warm front. You have warm air at the top that is moving up and over the cold air. Why is warm air going up and over? Well, you already know this because, again, I've said this so many times, but warm air, when it gets warm, it doesn't want to be close together, so it expands. As it expands, it becomes less dense, allowing that air to go up and over, so it rises. And so because this is going up and over at a very gradual angle, as you see in the picture down below, you're going to get some clouds because that warm, moist air is rising. As it increases in altitude, its temperature decreases. So therefore, that warm air rises, it cools, condenses, reaching its dew point, forming clouds. And so those clouds are going to give you rain. With every single front, we're going to see cloud formation, and we are going to see some form of precipitation. And that is because warm air is going to rise in all of them. But you need to know the type of precipitation you're going to get. And in this case, it is light to moderate rain. So I will let y'all pause this if you need to continue drawing. Otherwise, I'm going to continue to move on. I hate when my email does that. View, present. Okay. Now I'm going to move on. This is just a picture of a warm front. So you have the actual picture that you drew, but down below, and you don't always see this, but I thought this was a cool picture that I found. You actually see the warm front. So just like this has a slow, gradual angle, this has that slow, gradual angle. So this would have been a warm front moving into a region pretty far away from wherever this picture was taken, because they could actually see it. So this would have been that warm air because it cooled and condensed to form those clouds. And this would have been the cold air down below it. So I just thought that was really cool and wanted to show you kind of nature in action, I guess. So next front is a cold front. Your cold front symbol is going to have your blue triangles. Some people think of the blue triangles as like mountain tops because the tops of mountains are really cold, or some people think of them as icicles. So whatever can help you remember that the triangles are your cold front, because they may show you all the symbols in black and white and then ask you to label them. You can't always go based on color. So anyway, cold front is when cold air moves into the regions, and your type of weather are short storms. Okay, short storms are the key here. If you've ever, you may notice this sometime in the summer, it'll be really hot, and we know the temperatures are going to drop the next day. And so that night, there will be just like 10 minutes of big thunderstorms, and then all of a sudden they're gone. Well, that was because of the cold front that moved in. Or it may just pour down rain for about 5-10 minutes and then absolutely stop. Well, that would be a short storm. Your short storm could be a short thunderstorm, it could be a short rainstorm, or it could be a short snowstorm, depending on the type or the weather temperature that you have going on. So let's go ahead and draw our front. So again, you're always drawing your weather symbol going in the direction that the front is moving. So there are my blue triangles. So that's the direction that it's going to move. Now, some of you, you may have seen SpongeBob before. So SpongeBob, in one episode, I haven't watched this in a long time, but in one episode, they're doing a pizza delivery thing, and they're driving a rock around to deliver the pizzas. Well, that rock is very, very dense, it's very, very heavy, and it's just, going really fast and can bulldoze into whatever. That is also kind of how this dome of cold air looks. So you can imagine this dome of cold air, and then maybe you can think of SpongeBob sitting on top of it. There's SpongeBob. Yay, SpongeBob. Let's give him some pants and then some legs. And you don't have to draw SpongeBob, but that's just for fun. Okay, so there's SpongeBob. You can picture him driving this cold air, and imagine this cold air being just as dense as that rock is that he drove for the pizza delivery. So the cold, very, very dense air is moving into the region, and it is just knocking away all of the air that's in front of it. Well, the air that's in front of it is warm air. And notice this warm air is going straight up. Warm air. So that warm air is going straight up. If you think about our warm front, it was going in a nice gradual angle. This is not. This cold air is just bulldozing into the area, and it's forcing that warm air to go really high up really fast. Well, if you have air that's rising really, really high up and it's doing that very quickly, you are going to get massive clouds. And so if you wanted to draw like a big cloud and a lightning bolt coming down from that, you could. But because you're getting those big giant clouds, that's why it's creating these storms. Remember, you have your cumulus cloud, which are going to be your fluffy ones. But if those clouds continue to accumulate, you therefore get those big storms because they are just piling up so high. And the higher they go, just like Jenga, the higher the tower, the more unstable it is. So the higher these clouds, the more unstable they become. And that's why it gives you those short storms. On the next slide, I just have some pictures of a cold front, a real life picture like I did of the warm front. So if you need to pause this to finish up drawing, go ahead and do that. Otherwise, I'm going to move on. But before I move on, I'm going to give SpongeBob a pizza to hold. There's his little pizza. Okay, so go ahead and finish drawing this, and then we will continue on with our notes. So here is a cold front in real life. You have this dome of cold air, if you can kind of picture that. This dome of cold air that's moving into the region, moving your cloud, or it's moving the warm air up, which is causing that big cloud to form. This is not what all cold fronts would look like because this is a massive storm that's occurring, but I thought it was a kind of a cool demonstration of it. So. This is just showing you on the weather map, you have the cold front that has moved into the region, and then notice right where the front is, you have storms. So right here is where you have your storms. That's where the lightning bolts are occurring. So behind this air mass, this would all be cold air, because that's in the actual cold air mass. And this all would be warm air because that's in the warm air mass, which is why it's talking about mild temperatures. And then over here in the middle, you've got the storms. And I wanted to point this out because sometimes with fronts, people imagine these storms being massive things that take up the entire area of the whole front. They don't. These storms or these weather conditions, they are only occurring on that front line of battle. Everything that's behind the front line of battle is either going to be the cold air or the warm air, depending where the air mass is. So you have the storms right there, and this is just a little bit of rain as it transitions back into the warm air mass. So I did want to point that out. You may notice that as you look at weather maps or if you ever watch the Weather Channel. And this is the same thing. You've got, this is a reminder of high and low pressure. Remember, high pressure is going to have your good, fair weather, which is going to be clear skies. So notice there's no clouds over here. And then low pressure has that bad weather, and so that's where you start to see all of these clouds forming. So just a little bit of a review with that, and you can see the front affecting that as well. Next, stationary front. So I want everybody to get your hands and hold them up like you're about to give someone a high five, or do jazz hands. So spread your fingers apart. And then I want you to interlace your fingers, putting them together. And then don't close your hands, but just interlace your fingers and then push. If you do that and your fingers are all interlaced, then when you push against your hands, they shouldn't move. Unless you just have one arm that's freakishly stronger than the other arm, they shouldn't move. Well, just like when you have your fingers interlaced, which hopefully y'all understood that and did it right, that's how the stationary front symbol is. So the stationary front is going to show cold air moving in one direction, and then it's going to have the warm front symbol going out the other direction. So this is your stationary front symbol that you will need to draw. So just like your fingers were interlaced, the stationary front is interlaced. And like when you pushed on your hands, the reason that they weren't moving was because your arms are of equal strength. Well, when you have a stationary front, you have a warm front and a warm air mass and a cold air mass coming together. But that warm and cold air mass are equal strength, just like your arms were. And so when they push, they aren't actually going to move any of the air mass out of the way. The warm air mass is not strong enough to push the cold one out of the way, and the cold air mass is not strong enough to push the warm air mass out of the way. It would be like a tug-of-war thing, but tie. So they can't push one another out of the way. So what they do instead is they slide past one another. So the warm air mass will go in that direction, and the cold air mass will go in the other direction. Now, because these air masses can't just push one another out of the way and move on, it's slower. They're having to just slowly squeeze by side to side. That's going to make your weather linger, okay? So another weather condition to add other than steady rain is lingering rain. And I want you to put lingering because that's just a word that uses a lot. Some of you may know those people that just kind of linger. They'll walk up to you and just kind of stand there and not say anything. Well, they're just hanging out and not moving. They're lingering. That's what your weather is going to happen. So if you have rain for just a whole week straight and it's just not going anywhere, it won't move out of your area, it's probably from a stationary front. So it has the lingering rain. So go ahead and write down that symbol because I'm about to clear the screen so that I can draw what this would look like. Okay, and I'm going to erase the symbol now. Okay, so when you have your stationary front, you have the cold air, so cold air going in this direction. So that means I draw my cold front symbol pointing in that direction. And then on the other side of it, you have the warm air. So here is your warm air. And the warm air is also trying to push towards the cold air, but it can't. It's not going to be able to push it out of the way. So you draw your warm symbol going that way. Now, one thing that people tend to ask me is, how do you know how many triangles to draw versus scallops to draw? It doesn't matter in any way. If I wanted to keep drawing scallops, I could, and the triangles, I could keep doing all that stuff. There's no significance to the amount of arrows you're drawing. It's just how long do you want to make your symbol. So that doesn't matter at all. But you have the cold air pushing one way, the warm air pushing one way. Because of that, you have that interlocked symbol, and that's going to cause your weather just to sit on top of you for a long time. And so you typically get the clouds that are just kind of like stratus clouds forming. They're not very tall, they're just long clouds. So you can go ahead and draw that. If you're done, then I'm going to move on. Otherwise, y'all can again pause the video to catch up. And our last front, if the screen will move. There we go. Okay, our last front is an occluded front. So everybody say occluded. Occluded front is when you have 3 air masses that are coming together. Okay, 3 air masses. All the other ones have only had how many? 2. Well, now we have a third one coming into play. So 3 air masses are going to come together. Basically, you have a warm front. So when you're drawing this, I'm just going to erase this for a moment or cover it up. When you're drawing this, what you can imagine is you start out with a warm front. Because if you ignore this side that I'm putting the big black circle on, if you ignore that, that drawing looks just like your warm front drawing, or it should. You have warm air that is gradually going up with the cold air over on the bottom. So what's going on, if you can imagine, you have a warm front, and then boom, all of a sudden, you have SpongeBob coming in on that giant cold air mass, that big rock. So here's SpongeBob, and he's flying in, and he's just wrecking in to that warm air mass. And so because of that, notice that in this area here, there is no warm air that is actually touching where the ground is. So the warm air, and this is, you also need to write down this, it cuts off the heat source, aka warm. It cuts off the warm air from the ground, excuse me, whichever way you want to write that. So you have a warm front, and then boom, your third cold air mass, it comes in and it takes over. There's evil SpongeBob. Let's give him some pants again. Keep him appropriate. Okay, so he bumps in to that warm air mass, and you have no warm air on the ground. So all the warm air is up here, and you would write that down. So you'd have the warm air up here, and then you have 2 cold air masses on the bottom. All of the warm air is cut off from the ground, and because of that, the storm will die. So this is the weather condition associated with your occluded front. You cannot have a storm, just like you cannot have a cloud, if you do not have rising air. So like when we talk about high and low pressure, we know low pressure has rising air because that low pressure is bad weather, and all bad weather has a cloud. And the only way a cloud can form is if you have rising air that has moisture in it that can cool and condense. Well, if you have a thunderstorm or a tornado or anything like that, what fuels every storm is what we call a warm up draft. And it's called a warm up draft because it's warm air that is moving up. Why is it moving up? It's less dense. So you have this warm air that's moving up, and then all of a sudden, because SpongeBob wrecked into this other cold air mass, you have only cold air at the bottom. So this is going to prevent any more air from being able to rise, which is going to prevent any more fuel from being put into the storm. So therefore, the storm will die. So if you are in an area with a tornado and all of a sudden a cold air mass just comes into that area and cuts all the warm air off from the ground, then boom, you're in good luck because now your tornado will die. And hopefully your people won't, that's in the area. Okay, so that is your occluded front. The occluded front has a lot of weird weather associated with it. The storms dying is the only consistent thing we can really talk about. So that's why it's the only weather source I included here. So I'm going to go ahead and clear the screen. If you need to finish drawing, then again, pause the video. And how exciting, that's our last set of notes on front. Now we can finally talk about severe weather. So we're going to talk about tornadoes and hurricanes. And once we talk about that, we will be done with our weather unit. So this has been a very long unit. Please make sure you are working on that study guide, that you are studying. This is probably one of the largest units that we have this whole school year. And so you've got to make sure that you're keeping up with all the work and studying. But that is all for this video, and whenever we continue, we will move on with our severe storms.